All right, welcome to our first workshop of the quarter. Today we're going to be covering Godot. First, we have some quick announcements.
Yeah, I can go over that. So just a reminder that we do have our Husky Game Dev workshop next week. We'll be holding 2 sessions again, just like this time, just in case you guys want to, wait a Thursday instead of today. But yeah, please come to that if you're planning on participating in our fall game jam, and I'll get to that in a second. And then our second general meeting is going to be the week of midterms. So it's just going to be like a very casual type of meeting, no workshops or anything, just because it's midterms week. So if you want to come de-stress, have some fun, socialize, come to the second general meeting. And then the fall game jam will be the week after midterm, so after everyone's already done with the stress. And yeah, we'll be announcing the theme for that, so make sure you come the day of on our meeting, okay?
So here's the agenda for our workshop today. First of all, everyone should be downloading Godot if you haven't already. And then we're going to first cover the Godot fundamentals, and then we'll make Husky soccer.
Yay!
So you can download Godot from the Godot engine website. There's also a link in the Discord. So if we go to the workshop channel, there are a bunch of links here. There's a Godot website, and you can also download the project from here too.
Hi, Lizzie.
We just started. Okay. We can catch you up. So there's a workshop channel in the Discord, and there's a bunch of links here. You can download Godot from here and the project files.
Where's the work? Oh, I see it.
All right, and once you have it downloaded, you just unzip it. You should have 2 files here, and you can use either one. The bottom one just opens the engine with a console open, and it's just what the engine is saying, like it prints errors to it and whatnot. But you don't need that. You can use the top one. And if you have this error pop up, you're not able to support Vulkan on your computer, you're going to have to open it with OpenGL. There's no fallback implemented for some reason. So you're going to have to open your command prompts and just run the executable with this argument. So if we can have everyone open Godot real quick, make sure we don't have any problems, that'd be pretty cool.
One thing I will mention, Lizzie, you're on a Mac. I believe a Mac download is just one file, so you don't have to worry about any of that. It's just Godot.app.
I think I actually have Godot already, so it's perfect.
Make sure you have 4.5. Oh yeah, and make sure you have the 4.5 version.
Yeah, I think Taco got you around 4.4, so you should double check and make sure you have 4.5.
Oh, never mind, I guess I'm going to do that.
Well, we're just use my battery bank. There's 16%.
Does that plug not work?
None of them.
Unfortunately.
I don't think any of the table ones work.
Yeah, that's because these are dead.
Oh, unlucky.
It's
I
okay.
know that's a library issue right there.
Yeah.
All right, while everyone's getting that set up, we can cover some of the fundamentals.
And the project.
Oh, right. Projects in the Discord.
Wait, everyone has it downloaded already, right? And it's open? Any issues? Sorry, James, go ahead.
Yeah, don't interrupt me.
Oh.
All right. In the Discord workshop channel, you can download the project from here. It should take you to the GitHub releases, and you could just download the clean project here. And if you want, you can also download the complete project for reference. If you have any problems and you want to like double check with the finished product, you can download it here. So let's go ahead and download this.
Another thing I'll mention, the complete project is documented fairly extensively. James did a really great job of commenting basically every line of code.
Thank you, James.
So if you need to understand what is going on, look at the complete project. Which channel is that on?
It should be under workshop. So it's under topics and help.
Can you guys run into any problems at all at any time, please don't hesitate to ask for help.
You're so organized. Wow.
I know. Good job, James. Everyone say thank you, James. Thank you, James.
Yeah. Skip 2 classes to make this.
Only 2?
Only 2. Let me just close all my Godot instances. Alright, once you have the project files downloaded, you can just drag this from the zip anywhere. I put it in the desktop. And then you can open Godot. And it'll take you to your project manager. This will show all your projects that you already have. You should have, if you just downloaded Godot for the first time, you shouldn't have any projects here. And if you want to add the clean project that you just downloaded, you just hit scan, and then you navigate to your project folder. So this one I just downloaded. You just click inside the folder, and then you click select folder, and it should add it here. I already had it, so it's already sitting there. And then you just double click to open. It should load up. So we'll just wait here. Everyone gets to this point and we can move on with the presentation. If anyone has any problems, speak up, ask questions. Feel free to interrupt. Are we all good?
Wait, no, hold on. Sorry, I'm still looking.
Okay.
Okay, I can't find it. You think I could just drag it in Okay.
In the project manager?
Yeah,
you could drag it in too.
Yeah, you can drag and drop folders.
Okay, because I couldn't find it when I clicked scan.
Where's this close to?
Yeah, are we all good?
Yay!
Sweet. All right, let's cover the fundamentals of Godot. So first of all, what is a game engine? Well, a game engine basically provides tooling for creating games. There are also like game engine frameworks, which are different from engines. So frameworks are basically the programming libraries without the editor, like the visual editor. We have game engines like Godot, Unity, and Unreal. They have complete tooling and visual editors for you to use. The core engine loop across pretty much all engines is pretty universal. They're all the same. Like they handle rendering, updating game objects. They loop through the scene tree, pretty much all the same. Where they differ is usually their programming languages, their API, how they're implemented, and their architecture. But overall, once you learn one engine, you pretty much can transfer your skills to another engine pretty easily. So when you first open Godot, you should see this view. This is the editor, and in the center, number 1, we have the viewport. This is your game scene. This is where you'll see your game objects, if you have any models or sprites. At the very top, you'll see there's a 2D and a 3D mode. We'll be working in 2D primarily for this workshop. In fact, we're not using 3D at all. So you can switch to the 2D mode at the very top. On the left, number 2, we have the scene tree. This is where you'll have all your game objects or your nodes, as Godot calls them. And they'll be sorted in like a hierarchical scene tree. We'll cover that more later. Number 3, we have the file system. This is where you keep all your assets, all your files. And then on the right, number 4, we have the inspector. And this is where you modify properties of your game objects. All right, this is a very important concept. Godot's 2D space has the Y inverted. So usually when you think X, Y coordinates, Y goes up, but in Godot, Y goes down. And that's also like the standard for rendering on a computer. Y usually goes down. And the system is also used for UI. Yeah.
The 0, 0 is on the top left. I know that in some cases 0, 0 likes to be on the bottom left, but in Godot, top left.
Yeah.
I didn't know that.
All right, so Godot uses, instead of, if you've used Unity before, Unity has game objects. Godot has nodes, and they're basically the equivalent. Everything is pretty much a node. So 2D, 3D, physics, GUI, everything is represented by a node, and nodes have exactly one script or one behavior. They only do one thing. So on the right, we have a bunch of node examples. At the very top, Node 2D is like the base node for 2D stuff, and it contains like a transform, like your position, your scale, your rotation. And then all these other nodes below it extends Node 2D, and they add behaviors. Like we have animated sprite, which is just rendering a sprite to the screen. We have audio stream player, which just plays an audio clip. And then we have a bunch of physics objects. We'll get into that during the workshop. Scenes are a collection of nodes. So in the file system, you usually save your scenes in the files. And you don't save nodes, really. You save scenes. So if you have like a tree of nodes, you can save all of them as a group, as a scene. And scenes can be opened and edited individually. So nodes are organized as a tree. On the left, this is your scene tree. On the right, but it would be on the left in the editor. And nodes use a parent-child relationship. So a lot of properties are propagated down from the parent to the child. So transforms are propagated. What that means is if the parent moves, the child also moves with it. And if a parent is deleted, the child is also deleted. So here on the right is directly equivalent with this diagram. So we have the map node, and then we have a Husky and a ball node. They are children of map. And the Husky and ball all have like a sprite and a collision shape. And those are like nodes that add like physics to the actual Husky and the ball, and also adds like a rendering component, the sprite. Now the file system basically shows your project folder. All your assets are saved and imported into the engine as resources. This is like a special type of class that provides like an API to like the actual file and properties of that assets. For example, ball.png is imported as a texture 2D. Texture 2D is a resource, and you can edit properties like, oh, do you want to when you import this image into the editor, do you want filtering? Do you want the texture to repeat and whatnot? Project folder organization matters. You'll see a lot of example projects online. They just dump all the assets into one folder and call it a day. You want to practice organization early. It's pretty important. All right. Now the inspector uses this to edit properties of like nodes and resources, and properties are unique to each instance of a node or resource. So if you edit one node, it's not going to, change the properties of another node. And the properties are also of all the class of the current class of the node and all inherited classes. So you can see Husky inherits from character body, which inherits from collision, which inherits from node 2D, and so on and so forth. And you can see all the properties of all those classes there. So GDScript is Godot Engine's custom scripting language, and it's pretty easy to learn. It's a little Pythonic, a little bit. It supports dynamic and static typing. We generally recommend using static typing all the time. Dynamic typing, it's perfectly usable, but it's not really readable. When you go back to your code, you're not going to be able to tell, oh, is this a Boolean? Is this an integer? And on the right, we have code examples. So we have variables on the top, statically typed and one dynamically typed. And then we have functions on the bottom as well. And scripts are attached to nodes and resources that add functionality. You can only have one script per node or resource. So this is a little different from Unity, where you have multiple components per game object. Instead, in Godot, you basically split all those components into different nodes, and you basically construct like your character out of many different nodes instead of just one like physics object, and you attach a bunch of components to it. Just a quick overview of variables. You define variables with var. Types are declared after the name using a colon. And there are optional annotations that you can use when you declare a variable in a class outside of a function. So we have export and onReady. So what export does is basically it lets you edit the variable in the inspector. And onReady, it like initializes that variable when the node is ready. And that'll be important. We'll cover that in the workshop. We also have functions. Quick overview. Functions. There are some functions that are called by the engine. So we have like ready, which is like the equivalent to Unity's start. We have input. So whenever the engine receives an input, it'll call this input function to all the nodes in the scene tree. Process, which runs every single frame, and physics process, which is called every physics tick. So in Unity terms, process is update, physics process is fixed update. And here at the Godot, there are Godot documentation. So it's really useful. It has a bunch of like tutorials and very well documented code. Like all the functions in the engine is like really well documented as opposed to Unity's documentation. Please learn to read the documentation. It's super important to learn how to like read documentation in general. And here's the link to it. All right. Now we can begin. So when you first open the project, it's going to open to this 3D view. We're not going to be using the 3D view. We're going to be using the 2D view. And we can see in the file system, does everyone have this open? We're all good? All right. So we can see in the file system, we have a bunch of assets already. We have like a ball texture. We have a Husky texture. So these are all just pre-made. All right. And to get started, we can create a 2D scene on the left here. And it should create a node 2D. And here we can just call this like main. So you can double click to rename. And then we can Control S to save the scene. So we can save it under assets. Just call it main.tscn. So that should show up in our file system. You can see the scene is saved. And now we can start adding nodes. And feel free to interrupt while I'm doing this. If I'm going too slow, you can tell me. If I'm going too fast, yeah. So, oops. So we can, from here, we can add child nodes. Let's make another node 2D and call it like map. And so we'll add all our objects to this map. And then let's create our Husky. So we're going to use a physics object called character body 2D. And what this will allow us to do is not only interact with physics, but also control our character pretty easily. And we can call this Husky. Let's give our Husky some collision. So we need a collision shape. And we'll give it a circle. And now we need to actually see our Husky. So let's also add a sprite. Oh, I kind of glossed over it, but on the right here, under collision shape, in the inspector, you add a shape. and you just click this empty, and you click circle, and it adds a circle. And you can zoom in the viewport.
Any questions thus far?
I think we're all good.
How did you add the image to this?
All right, the sprites.
It was a child.
Yeah, as a child node, sprite 2D. It should pop over here. And then here, we just click on this sprite. Make sure that you're clicking on actual nodes so it pops up in the inspector. And then under texture, we're going to do a quick load. And we're going to load our husky.png, which should be this one.
Oh, what? Oh my god. Oh.
So it should pop up with this. Right, so this is what we call a sprite sheet. It's a bunch of sprites on a single image, and we're going to use all of these images to make an animated sprite. All right, so right now we're displaying all of these huskies. We only want one at a time, one frame at a time. So we're going to go into animation. And under animation, we have the number of horizontal frames and the number of vertical frames. So we have 8 horizontal frames. So we're going to set this to 8. And it should reduce this down to 1 column. And we have 4 vertical frames. And there we go. Now we just have the 1 husky frame. And the way you change the frames is by incrementing this frame variable right here, and this will change the actual frame on the sprite sheet. You can also use the frame coordinate. So like, this is what we'll be using. We'll be using the X and Y coordinate. And now, just a little thing, we're also going to be changing the offset. So like the bottom of the husky is going to be aligned with the circle, this center of the circle. So I think about -6, maybe -8 will work. Yeah, that's nice. And then I also want to adjust the circle shape to be just a little bit smaller to fit the husky. So we can go back to collision shape. Under shape, we'll set the radius to maybe 6. Yeah, fits nice and snug. All right, any questions so far?
Wait, what was the radius?
6.
6.
Did you show that one?
Yeah, could you show them?
The circle. So we go back to collision shape. Under circle shape, there's a radius. If it's not showing up, you have to click on the circle shape here, and then you can set the radius here.
Yay!
All right. So if we hit play, it'll ask you to select a scene. We'll select the current scene, and it should pop up with this window.
What the?
Uh-oh, he's in the corner. So, yeah.
For me, it says could not start some processes. Press play.
He's like a pixel.
Kaden, can you fix that?
What does the output say?
I also. Oh yeah, so just
Oh,
click.
maybe?
Just in this video.
If you
Yeah.
I've never heard of that error before. You good? All right. Does everyone have this so far? We're all good?
Which one was it?
Just press play. It should be in the top right here. So you just press the run button.
Yay, now he's a little pixel in the corner.
Yeah, so there's a problem here. Our camera, it's not really centered on our husky right now. So what we're gonna do, exit out the play, and then here in our map, under map, we're gonna add a camera. And make sure it's a child of map and not husky. So you should see the camera is like below husky. If you like minimize that, it's like a sibling of husky. And now with this camera, if we run the scene, Now our Husky's in the middle.
Oh,
Yay.
I know. We've been doing it so wrong the entire time.
All right, now let's make our Husky move. We're gonna make our first script. So under assets, we can just right click, create new script. And it should bring up this window.
Hold on, James.
Yep.
Motion mode.
Call it motion mode.
I mean, yeah, that's actually important. Okay, go to Husky,
Oh.
your Husky game object, or node, sorry. And then under motion mode, we want to use floating.
Basically, they offer two different modes for like top-down and like side-scrolling.
Yeah.
By default, it's like the side-scrolling mode, which means the character has gravity, which we don't want. So by floating mode, it's going to make it more like a top-down thing, which is what we're actually trying to make.
That's cool.
That is very cool.
Actually, it doesn't apply gravity.
My fault.
It just has to do with like the directions of velocity. Actually, earthquake. Okay. All right, let's make our script. So under assets, right click, create new script. And it's going to say language GD scripts. That's what we want. Inherits, we want to put in character body 2D.
Oh.
And make sure you type it right. It will tell you if the script's name path is valid. And then we can call this script, instead of new script, we can call it Husky.
Husky.
All right. And then we can hit create. So here, it should show up on the left in the file system. If you double click it, it will bring up the script editor. So this is built into the editor. You don't need to open up like VS Code to edit scripts, which is very nice. And we can start scripting. So the first thing we want to do is make our Husky move with input. So we want to use one of the functions we introduced earlier, which is the input function. And you can see as soon as you start typing, there's autocomplete. You can see if you have this first option up here, you can hit tab to autocomplete it. And then from here, before this function actually, we should define an input move variable. And this is going to be of a type vector2.
Why not vector 1?
Because there is no vector1.
That would be just float.
Okay, just a question, y'all. Just a question.
Okay, well, a vector2 is basically two floats. It's an x and y component. In fact, if you hover over it, it explains what it is right there. All right, from here in this input, normally you would read this event, but for the purposes of this workshop, we're gonna just pull the input singleton. So an input move, we're gonna set this to vector2.0. And then we wanna write to the x and y variables. So we're gonna do like a plus equals input dot is action pressed. And then you'll see like we have a bunch of UI inputs. We actually haven't defined any input actions yet. So we're just gonna leave this for now. And we're gonna go up into project settings. Ooh, it's on my other screen.
It's called for every instance that's, this is called for every event that happens with an input event.
Yeah.
So even best key that it's not necessarily bound, it will trigger trigger a call to input.
Anytime an action is pressed, or you define your actions in the input settings, or anytime a key is pressed or the mouse is moved, it will call that input function.
Yeah, it's up to the code itself to filter out what
Yeah.
it wants and what it doesn't want. It will get called for every invocation you are correct.
Oh, okay.
All right, so in our project settings, we can go to input map. You'll see it's empty right now. And we need to make 4 actions to make our Husky move. We should have move up, and you could just hit enter and it'll add the action real quick. We need move down, move left, and move right. All right, so we have our actions here, but now we need to define keys for those actions. So on the right here, you hit this plus icon, and we can just press any key. So for move up, we want to use W. So we just press W. It's gonna scan what key we just pressed, and it's gonna say, oh, we just pressed W, and we just hit OK. So for move down, we want to use S. Move left, we want to use A, and move right, D. And we should have our input set up like this. Are we all good? Great. Okay, so that's our input setup. And now in here, when you type in your quotes, you should see your actions here. So move down, move left, move right. All right, so the x-axis, we want to add 1 when we're moving right. So we're going to use move right. And it's throwing an error here, an invalid operands float. So this actually returns a Boolean. We need to convert it to a float. All right. And now for input move.x, again, we want to subtract 1 if we're moving left. All right. And then again for the y. Oops. Now this is where that coordinate system comes in. You don't want to add when you're moving up, you want to add when you're moving down. So move down, you want to add to y, and then minus equals floats dot move up, you want to add to y. All right. So we should have that. Now we need to do something with this input vector. So in our physics, we're going to make a function called physics process. It should be this one. We just tab to autocomplete that. What do we do from here? Oh, right. So we're using a character body object, and to make our character move, we don't want to set the position of the character, right? Because that'll just teleport the character, and it's not going to interact with physics. So we just set the velocity equal to our input move. And we don't have to deal with delta, because if we hover over velocity, it's just the velocity in pixels per second we want to use. And we also want a move speed too. So we could just put in a magic number here, but we don't want magic numbers. We want to make a variable. So at the very top, let's do an export, because we want to edit this in the inspector. Var move speed. And we'll give it a float. And I think I used 64 in the final project. Now you see this export move speed. We're going to use this in our velocity. And then after this velocity line, we're gonna call a function called move and slide. So the character body is gonna read this velocity and move and slide with it. All right. Do we have all of this? Are we all good? Sweet. All right. Now, if we go over to our Husky and click on it in the inspector, you'll see that we have nothing because we have not attached a script to it. So in the file system, we're gonna click and drag this script over Husky, and it should attach the script. So you'll see here, down here, it should say script husky.gd, and at the very top, you should see your move speed variable. All right, and once you have that, you hit run. And if you press your input buttons, WASD, it moves the Husky.
So cute.
wait a second for everyone to catch up. I need a minute to open the final project. What's next?
You can walk off screen.
Oh, right. All right. Does everyone have this? Are we able to move the Husky?
That only moves right.
It only moves right. Okay. Do you have this properly set up?
It's because they change these pluses to minuses because you want to.
Oh, yeah. You want to, for move right and left, you want to use X, and then for move down and up, you want Y. Yeah.
Okay.
Let's see.
That
And you have these plus and minuses.
The project settings, did you add the input methods?
I'm pretty sure I did. Yeah.
Maybe I should have went with the if statements. It's
I
fine.
had to click on the window after the name to make it look.
Oh,
I might put myself on tomorrow.
Yeah, use the if statements. I think it's. Yeah.
Teacher James, question.
Oh, what's your question?
Wait, show me. Maybe I forgot something. So when I play it, and hold
It's
on.
so odd. It's like I hit the
It
button.
stops after a while. No, I'm still holding it down.
Oh, this is so weird. Okay.
Can I see the code? Is action. Oh, you're using just press. We want to use is action press.
Oh.
Yeah, so
So just remove just.
Just will only occur like the one time it is just pressed and not.
It holds it for one frame, one physics frame, I think.
Yeah, I think so.
All right, are we all good? Excellent.
James, you might
Oh.
have an issue with you don't have a movement of the Husky.
We don't have movement.
I have like the code.
Yeah,
The code matches. All right.
Yeah.
Can you check your project settings input map?
Yeah, really weird. So,
Make sure it maps.
Yes.
Looks good.
Yes.
Are the names correct? Move up, move down. Okay. And they match these.
The code is good.
Input,
it's so weird.
input move equals vector 2 to 0.
We're
We're using velocity.
It might be. So what's the issue?
Oh, it's when I press W, A, S, E.
Maybe this one, the input.
Yeah, I'm gonna try resetting it.
Me and the girls.
And then
Yeah.
yes. There we go, we got it.
Okay, weird.
I don't know why resetting it to 0 actually makes it work, but it does.
I didn't add that line. So, that way.
Oh, it does,
Yeah,
'cause
it's fine.
we're-
I just did it.
In batters because we're incrementing and decrementing it
Oh, I'm at the input move equals vector to
Yeah.
0.
here.
So,
Right.
I just added in, it works now. Boom.
Yay.
This line?
Yeah, I don't know
Yeah,
why
that line's important. Because
Well, I
otherwise,
added it, I don't know.
otherwise every input, it's just gonna, if you like hold down one button, it's gonna add 1, 2, 3, 4, 5, 6. It's gonna go on infinitely. You want to reset it every time you read the input.
It's also important why we're adding right and subtracting left is so that if you press both keys at the same time, it cancels all movement. Instead of like having it go like pick a direction or just kind of jitter between the two directions, we just want it to not move. So that's why we add one and subtract the other.
All right. Is everyone good?
Yeah, I'm good now.
All right. Now, if you noticed, our Husky moves, but it's not very animated. It's very static. So let's make some animations. So over here, under Husky, we're going to add another child node to Husky, and we're going to call it Animation Player. So it should add an Animation Player node, And you'll see at the very bottom, we have an animation editor. And here we'll be creating our animations. So the very first animation you want to create, this will be for pretty much all animation players that you make, is a reset. So the engine's going to automatically add this animation for you. What the reset does is every time you save the scene, it's going to reset all the properties that you changed to these values. So under reset, you click on animation new and then create a new animation, call it reset. And it has this like special little icon here too. So on the left here, we're going to create a new track, and it's going to be a property track. And we're going to select the Sprite 2D under Husky. And under Sprite 2D, we're going to specifically use frame coordinates X. So we're not going to use frame. There's a reason for this. I'll explain it later when we get into animating the Y variable. So here you just select X, and it should bring it up here. And you'll see that here it's using seconds to snap. We can change it to frames per second just to make it a little easier. And here you can see your animation length. We can change it to 1 second for the reset animation. It's only going to run for 1 frame, but it's just nice to set it. And then here we'll add our first key. Super zoomed out for some reason, but you can zoom in with control and scroll. So on the very first frame for reset, you want to add a keyframe. Yeah, you just right click and insert key. And that should just be good. It'll reset this the X frame of the sprite to 0. All right. Also switch to 2D view so we can see what we're animating. All right, let's make our first animation. We're going to call it idle. And this animation is going to play when he's not moving. So again, we'll add the same property track, sprite 2D, frame coordinates X. We'll go ahead and make the FPS. Hey Wyatt, make the FPS. Let me check my project. All right, we're gonna set the FPS to 8. And then over here, instead of duration in seconds, it's now the number of frames. We're gonna set it to 5. All right, now here, every second, we're gonna insert a key. And the first one will be 0. The second key will be 1. Third key will be 2. Oops, did that change? 2. Oh, it's not change. Make sure you click on the keyframes because it's a little janky and unclear which one you're editing. And then number 3, I'm gonna change this to 3. And we should see that if we hit play, our sprite frames change. Actually, make this a duration of 4. My bad. It shouldn't be 5, it should be 4. So if you hit play, you should be getting this. Is everyone good?
No.
Okay.
Wait 1 second.
Okay, yeah, you want to insert a keyframe every 1 frame. And you want to make sure that the value of each keyframe is increasing by 1. So you have to click on each keyframe individually and make sure the value is changing on the right. Is everyone good?
Wait,
Okay. All right, so we hit play. and you should wag his tail a little bit. We want to make this animation loop. So on the right here, we just hit animation looping, and it'll loop our animation.
Oh,
Okay. He's wagging his tail. All right, does everyone have this?
Yes.
No.
What's it?
Yes, you just choose the value.
What's up? You can catch up. That's pretty easy. We're not too far. I mean, we have like 10 lines to go so far. You can totally catch up. Just like, I mean, you use Godot. You can copy the tree. You got this. All right, are we all good? Excellent. All right, let's make our move animation now. So instead of creating a new animation, we can instead duplicate it. We'll call this move. And it should keep the same keyframes here. Now here, for the first keyframe, we want to change it to 5. And if we update this animation, yeah, so this will be the first. No, it should be 4. It should be 4, not 5.
Wait, teacher James, I missed it. What did you do?
So from idle animation, we're making a new animation. We duplicated it, and we called it move.
Oh.
So it should make another animation called move. You click on animation, and there's a duplicate button here. A little bit. It seems like I was going a little. Like everyone was like waiting on me earlier. Yeah, we have to take photos of people who take Red Bull.
Giving me the same vibe as when Joe was at picture. We weren't there, but he had us all pose Red Bulls for
Yeah. There's a Red Bull thing here. Like a couple students rep it and they give us free Red Bull.
Okay.
But you have to take pictures. So.
Sponsored.
Hashtag sponsored. We're getting millions of bucks for this.
Let's put your. On startup.
Unless I run a certain kernel on my
What class is it? 350. It's just this.
so
Oh, I have to go too.
That's fine. Do you have to like wait for it to crash to reboot?
It's okay. For those who are leaving, this tutorial is being recorded, so just check back in the Discord.
Yep, it'll be uploaded somewhere, probably YouTube.
Hi guys, hope you learned something new. I learned a lot of things. I Hey, you know what? Even though we did Godot for 3 years, we still learned something new from James.
Yeah, there are so many different ways to do things.
But he does it the easier way. We do things very hard.
You shaking your head at not the hard way. I did making the scripts. That was the hard way. Bye guys. All right, where did we leave off? Move animation. Does everyone have a move animation? All right. Yeah, you just duplicate the idle, and it should be the same animation.
They didn't have an option to idle to duplicate for some reason, so I just had to.
Wait, what?
Yeah, I don't know. It was just grayed out no matter what happened. So, but like it takes 30 seconds to just remake it.
Oh, I had a duplicate button.
Huh.
Yeah, let's just straight out. I don't know.
Did they have the animation player selected?
Oh.
No, that might have done it. No.
Oh, okay. Yeah, you want to select the animation player. And then you can duplicate. All right, let's change to our move animation. And it's going to have the same keyframes. We want to change the keyframes. So the first one will be 4, then the next one 5, 6, 7. Okay. Okay. Yeah, that's funny.
Oh, it just the sense, like 4, 3, 2, 1. Or what? Oh, 4.
No, it ascends.
Yeah,
Oh.
4, 5, 6, 7.
where did you learn to count?
Excuse me.
All right, and if we play this animation with the new keyframes, we should get a run animation.
Who did the art for this?
I did.
It's really good.
Thank
I like
you.
it a lot.
I spent a lot of time, especially animating the tail.
I love that.
All right, it seems a little bit slow. We could probably speed this up a little bit. So if you change the FPS to maybe 12, you can see it's going to be the same speed. We have to manually move the keyframes over. It's one of my gripes with Godot.
That's lame. I should have just stayed connected.
It doesn't tie it to frames. And then we have to change the length again.
Oh, yeah.
After you do that. Yeah, but once you do that, set it to 12 FPS and move the keyframes again. You can see we have a nice run animation. All right, and those are the only 2 animations we need.
He's so cute.
Yeah. Anoop recommended that I make his tongue stick out.
Yes, you're welcome.
That's a great design
Equal
choice.
2 gray dots.
Yeah.
Don't forget that.
Could you click on one of the frames so I can see it on the inspector?
Yeah, so the first one will be 4.
0, 4, then...
Yeah, you don't have to change time.
Okay.
You just change value.
Mine looks choppy. I thought maybe it was something on that, but I guess not.
Should be 5, 6, 7.
Oh! Yeah. That's what it was. Okay.
All right, so everyone has the idle and move animations? You're good to go? Cool. So if we go to, just for demonstration purposes, if we go to Sprite 2D, you can see on your frame coordinate, our Y coordinate is not being animated at all. This is because we'll be setting it in code with our move direction. So if we change that, he changes directions. So we'll be setting this in code later. Yeah. There are many different ways to make directional animations. This way I found to be the easiest. Some people make multiple one animation for every direction. So you'll have like 8 animations, right? But that's really tough to manage. In one of my games I was working on, it was like a year-long project. I had about like 1,000 animations because I had 8 directions for each animation. It was just a pain to manage. So I made this new system of just animate one coordinate, the X coordinate, and then use the Y coordinate. And you just have like one animation. It's very nice.
Awesome. I like that.
Teacher,
Yes.
I have a question. So if you change the values, are you basically just saying like...
Yeah, you're selecting a frame, one of those frames.
Oh, so you're selecting like 4, 5, 6, 7?
Yeah.
What's this one?
That's 7. The first one is 0.
Yeah, it starts at 0.
Oh,
The
it starts
first
at 0.
row and the first column is 0.
6, 7.
Yeah.
I understand.
All right. Now let's make these animations used in our script. So if we go back to script, we can minimize the animation tab. In our physics process, we're gonna want to play the idle animation when we're not moving and play the move animation when we are moving. So we're gonna do if velocity is 0 approximate, then we're gonna play the idle animation. You don't have to copy like the comments.
I will copy the comment.
Oh, right. Before we can change the animations, we need to reference the animation player. So up here, under export, we're going to do an onReady. And if you remember, onReady is executed when the node is ready. So how ready works is when the scene is first loaded, the scenes are added, the nodes are added sequentially, like based on where they are in the hierarchy. So map is added, then Husky, then collision shape. So when they're added to the tree, there's another function called enter tree. You don't have to type this. So there's a function called enter tree, and that's called first when it first enters the tree. And then once all the nodes are added, it's going to go back. The engine is going to go back up the tree and call onReady, and it does it in reverse order. So from the bottom to the top, and so that makes sure that all the child nodes are ready before the parent nodes, because the parent nodes are what reference the child nodes usually. That's basically good practice. You want parent nodes to modify child nodes, not the other way around. All right, so onReady, we're gonna make it a private variable in Godot and Python. You prefix your variables with an underscore, because in Godot there are no private or public variables. It's all public. So we want to prefix with underscore. I'm gonna call this animation player, and it's gonna be of type animation player. And then we're gonna use the $sign. This is shorthand for get node. So we'll just use the $sign and then animation player. And then because there's an error, you want to cast it as animation player. Otherwise, it's going to throw like, oh, this is a node, not an animation player. So you want to cast it. All right. And so what this does is where this script is attached from this Husky, it's going to get this node from this path. So this is called a node path. And it's going to find animation player underneath Husky. So animation player is there, and we're just getting that node. Question?
So it searches like down, I guess?
Yeah, it searches relative to, so if you've used like Linux or Windows, right, in the command prompts, you can use like ... to go up a parent, and then like folder, and then file, right? So it's basically the same thing in Godot to navigate through the scene tree.
How would you search up the tree, I guess?
Oh, yeah, you just do parent. Like you can go...
I mean, in Godot.
No, that works.
Yeah, it's the same thing. It's the same thing. So in here, let's say I want to get to main. We could just do ... /...
So
I think that's it.
searches like 2 levels up.
Yeah, because Husky.
I think... Ooh, I have to put in quotes, right? Because of dots. And that should be, so that should go to map, or actually you don't need main. So that'll get the main node. If we want to get like camera mode node, we have to access it as a sibling. So it would be camera 2D.
Nice.
Yeah, and I'll get that as a sibling. But generally, you don't want to get nodes that are parents or siblings. You always want to get nodes that are children or grandchildren, and so on. All right, let me just put that back as animation player. All right, so that will get our animation player onReady. And then in our velocity, under velocity, we want to do a function call to play, and we're going to call our animation idle, right? We have an idle animation, and it's called idle. Oh, also this pass, I type this all the time just out of habit. The pass just means it's an empty line. It doesn't do anything. But like if you have like an empty if statement, and you just leave it blank, it's going to throw an error, right? It expected some code. So I like to type pass right afterwards, so it just gets rid of that error.
Is that ampersand a reference to a memory?
It's a string name. So there are two different types of strings. There's a normal string, right? And then there's a string name, which is just an ampersand before the quotes. And basically what Godot does is it caches string names, and it does, instead of like when you're doing equivalency checks, so with strings, it has to go through each and every character, right? With string names, it actually hashes it, so it's an instant comparison, right?
So it's an optimization, but not the same type of optimization as like references in C++.
Yeah. All right. Now we want an else after our if statement, and we want to play the move animation. And that's it. Actually, I'm going to remove these just to be succinct. All right. Does everyone have that?
I have a question for you.
Yes, sir.
The reason move speed doesn't have an underscore at the start.
Because it's a property that we modify. So generally when I make export variables, I make it public. So because I mean it to be changed, right? I intend it to be changed. And if it's like exposed in an inspector, right? I just expect those to be public variables. You can make like export underscore move speed, but like just in my mind, what I prefer anytime I export, I make it public.
And I should reiterate, public and private don't really exist in Godot as much as it's just a naming convention.
Yeah.
So if we prefix things with underscore, we intend it to be like private to the class, and we don't want other people to call it. It doesn't actually stop people. It's just basically an honor system.
All right. So once we have this, we can hit play, and we should see. It's a little small. Oh, right. It locks it up here. If you want to full screen it, you can stretch it to fit the game workspace. All right. We can see that he has an idle animation, and if we move, he plays the move animation. Look at him go. But we don't have directions yet, so that's what we'll be doing next. Does everyone have this working? All right. Now we get into the fun math stuff. Let me just. I don't have this memorized, so I have to reference it. Okay. You don't have to understand this math, but I use this math all the time, everywhere, to convert a move vector into the row that I want to draw the sprite with. Right? So, looking at my code. All right, if the input move is not 0, then I want to read that input move and change the direction of the sprite. I have a constant, the number of sprite directions. So if we look at the sprite sheet, you can see that it has 4 rows, and those are the number of directions that I have. So I have a constant integer with just 4. And constants are basically the same as variables, but they're constant. You can't change them. It's really just like convention that you do it. And Godot enforces that it's constant too. So, all right. Now with sprite directions, after that, we want to find the move angle with the down vector and our input move vector. So what this is doing, since the very first row is our Husky pointing down, we want to find the angle of the move to the down vector. Again, you don't have to understand all this math because it's about to get a little whack. So we're going to find the interval angle, and that's going to be converts sprite directions to a float times move angle divided by tau. And that basically converts the angle from radians to a -1 to 1 range that we can use to find the sprite row, which is an integer. This is our actual 0, 1, 2, 3 to map to this sprite frame. Pause mod, which is just wrapping, and then rounds the float to an integer, and then wrap it positively with the sprite directions.
Oh my god.
And that's it. We don't.
You don't have to. Again, you don't have to understand this.
And truthfully, we debated on making this just something that you copy paste.
Yeah.
Because this also changes depending on how exactly you want to do animations.
Yeah. So this changes with how you organize your sprite sheets too. So you have to redo a bit of math, or don't do math and use a whole bunch of if statements, like a couple hundred if statements, which is fine. I prefer doing that. Years of reusing the same code. I don't remember. I use this code everywhere for all my top-down 2D games. Yeah.
And what's the? I don't know if it gets cut off there. Is it just DAU?
Yeah, it's just tau.
Oh, okay.
It's 2 times pi.
Oh, that's good. Oh, okay. No more errors.
All right.
That's
Does
good.
everyone have this? Make sure you have this exactly. All right. Now we want to change the sprite y coordinate. We're finally getting to it. All right. So on ready, I'm going to add another on ready. I'm going to call this sprite. I like to omit the 2D part because it's kind of like a suffix, but it's your preference. It's not animation. It's sprite 2D. And it's called sprite 2D in the scene tree, and we're going to cast it to a sprites 2D. So you should have that. So that's going to get this sprite object under Husky. All right. Does everyone have that? Because I have to scroll down a bit.
Do each of these colors have to have an already annotation, or can you group together so you aren't like spamming like 50% of your lines?
Yeah. So what onReady is basically so there's a ready function. In Unity, this is equivalent to the start function, and in the start function, that's where you get your components usually, right? But in ready, this is also where you use animation player equals animation player as animation player, right? This onReady annotation is just like shorthand for this inside the ready function. So I like to use the onReady annotation. Some people like to put it all in the ready function. I think it's just cleaner if it's in onReady annotation.
If you do want to use onReady, you have to put it in every single variable that's being assigned onReady.
Yeah. So you have to use the same annotation over and over.
Double my productivity by putting all of my double my productivity in lines and codes with this one simple trick.
Yeah.
I think you can also combine it into the same line, but generally we just like to split it into two. One line for the onReady.
You can also do a region in the code so you can collapse it.
Oh yeah, there are regions in Godot too. We have a $region and end region, and you can just collapse it. And you can give it a name like my onReady variables.
Oh, wow.
All right, moving on. Don't type that ready function. That was just. All right, everyone has a sprite, right? We're all good? Cool. Let's change that sprite. So under sprite, we're going to change the frame chords dot y coordinate. Finally. And we're going to set it to sprite row. All right. And once we have that, we can run the project.
What? Wait, go back. I have to go back.
It's one line.
Sorry, you fell my phone.
Typing at 30 words per minute.
Sorry, I'm on the phone. Be mad at me. Okay, I'm done.
Awesome. Now, if we move, he changes his directions.
Oh, what?
Fantastic.
And he doesn't change directions for left and right and down.
Then you did it wrong.
Can we look at the market?
Yeah. Yeah, you need the code exactly. I know it's a lot of math, but
I just don't type very fast, so it's not good.
it's all good.
Okay.
So we'll just wait a while for everyone to have this direction changing. And this is the most complicated code we're gonna get. Probably the most. There's another section that's a little, that once we get into physics, it's a little more. What time is it? 11:20? Kaden, do you think we'll have time to get to the particles? I don't know how much time.
We have another workshop though, right?
Yeah, we have another session tomorrow, but it's gonna be like
Okay,
the same. It's a repeat. It's not a continuation. All right. We have a moving Husky. Everyone has this? Changes directions? Sweet. What?
Oh, are you adding it? You might be adding it, not finding it. I think I found it. Yeah.
Yay! Thank you. Okay, now I have it.
This is so silly.
Diagonally? Oh yeah. I completely forgot about that. All right, to fix that, so if you notice that if you move diagonally, the Husky moves super fast compared to the cardinal directions. So under input move, right here, when you set the velocity, we're going to call a function called normalized. And that basically, if you have a diagonal vector, it's going to be 1 to 1, 1 comma 1, right? X is 1, Y is 1, or negative 1, or whatever. The length of the vector is greater than 1, so the speed is going to be greater than 1. So we're calling normalized to make it a unit vector. So it has a length of 1.
Okay.
Is that the most simple explanation? But yeah, normalized and diagonal movement should be fine now. Yep. E. All right. What's next? Let's add the ground texture. Yeah, so we're not just a Husky in the void. All right, so on your map, we're going to add another child node. I'm going to call it a sprite 2D again. And make sure it's under map and not under Husky, so the ground doesn't move with the Husky. And in texture, we're going to do another quick load. And there's going to be a ground.png. And then at the very top, make sure you hit 2D so you can see it. And right now, our ground texture is drawing over our Husky. We don't want that. So on the right in the inspector, we're going to go to ordering, and we're going to set this z index to a negative number. So maybe like -16. And now, the sprite is drawn underneath the Husky. Everyone has this? Good. All right, now our ground is a little small. Our Husky doesn't have much to run on. So let's make it a little bigger. So to make our texture repeat, we can go into region. We have to turn it on. And it's going to make our texture disappear, but this will be fixed in seconds. We're going to give it a width of 512 and a height of 512. And that will make our texture super big, but it has this weird stretching effect. So make sure under rect, width of 512 and height of 512. And you should get this big square.
Where's rect?
It's under region, so you have to enable region. All right. Once you have that, we want to make this texture repeat instead of stretching, doing this weird thingy.
Yeah.
So under texture, we're going to go repeat and then enabled, and it should repeat the texture. Now, in an actual game, you'd probably use like a tile map. That's a separate node, and we're not going to get into that for this workshop. We're running low on time already, so we're just going to use a big sprite, and repeat the texture. All right, now he has a bunch of grounds to play on. That's great. Next up, yeah. All right, what's next? We want to add a ball now, right? We want a Husky to have a little ball to play with. Oh, are we all good? I can wait. Are you heading out, Kaden? Alright. Bye, Kaden. Good luck tomorrow.
I'm gonna be
Are you going to class?
What?
Are you going to class?
I think I am because I'm a little afraid of the professor.
Alright.
Maybe.
I'll go too.
I skipped class
What
to make this
professor?
workshop. For 51. I've been skipping that class to make this workshop.
Wow.
Oh,
It's dedication.
he's chill.
If she's chill, I don't know, you want to skip it?
If you're doing
I'll go.
well,
I'll go just in
you're
case.
not trying to opt in on the 552 main where I like a fourth of the class is thinking about doing.
Wait, really?
I think there's a fourth. There's something like 16 people. It's less than that.
Oh, you mean now we have everyone that actually
I should-
goes to class?
I should head out and let this keep going, so.
Alright. Bye, Kaden. Okay. Are we all caught up? We got the ground texture? Sweet. Let's make our ball. So our ball is going to use a different kind of physics object. It's not going to be a character. It's going to be a rigid body.
Trying to get ahead.
Yeah. All right, and we'll call this ball. Very original. All right, once we have our rigid body, we're going to basically do the same thing with Husky. We're going to add a collision shape. We're going to add a sprite. Collision shape is super simple. It's a circle, as you would expect. And then the sprite, also super simple. It's just the ball sprite. So ball.png. And yeah, it's basically the same thing we did with the Husky. And you can also move the ball over so it's not on top of the Husky with the move tool. Should be in the top left in the viewport. It's called move mode. Or you can press W, or you can set the transform property right here. And put it there. All right, everyone has a ball, a collision shape, and a sprite. We can make this collision shape circle a little bit smaller to fit it. I think it's about 6.
I did 6.
Yeah, 6 is fine. All right, and then one more thing. Under linear and angular on the ball, we're going to add some damping. So when we hit the ball, we want the ball to slow down, right? There's no friction implemented right now, so we're going to use damping, and we're just going to give it 2. So when we hit the ball, it's not going to go on forever. It's going to slow down, which is what we want. All right, so now we have a ball. If we hit play and try to move into the ball, nothing happens. This is because we have to apply a force to the ball. Oh, one more thing. Before we get into forces, you'll notice that when the Husky is like underneath the ball is drawn on top of him. If we go over to map, click on map, and then under ordering, we should have Y sort enabled and set that to true. And what that will do is draw the sprites in order of their Y coordinate. So anything below another sprite will be drawn on top of it.
This is way easier than Unity.
Yeah. Y sorting in Godot is so easy compared to Unity. It's insane. All right, and now if we're below the ball, we're drawn in front of it. Very nice. Yeah. 2D in Godot is so much easier than Unity, for sure.
Yeah.
All right. Now we have to apply forces to the ball. We want to be able to kick the ball. So if we go to our Husky script, we're going to change one of our lines. So our move and slide, if we hover over it, it actually returns a Boolean. And that Boolean tells us if we collided with an object. So we want to detect if we collided with the ball, right? So I'm going to declare a variable called collided, make it a Boolean, and set it equal to the function. All right. And then just my preference, I prefer to do all my physics like before everything usually, or you could do it after. It actually doesn't really matter. We'll do it below. Okay. So if collided, and I need to reference my code for this. We're going to need to get that collision information. So we're going to do var collision kinematic collision equals get last slide collision. So this is a method found on character body, and it populates a collision information object whenever you call move and slide. And so we're just getting that collision object with this method. And now we want to check if what we collided with was a rigid body, which is what our ball is. It's a rigid body. So we're going to do, we're going to create a variable called rigid body. And we're going to set that equal to the collision dot get collider, and then cast it to rigid body 2D. And so this is, we're attempting to cast the collision collider to a rigid body. If it's not a rigid body, it will return null. So we should check with an if statement. If, and you can do rigid body equals null, but you should use the function is instance valid. Because sometimes variables can be not null, but invalid. Like, it's a whole engine thing. I can't explain it. So use the is instance valid instead of checking if it's null. And then from here, we want to create an impulse variable. So this is the impulse force we're going to be applying to the rigid body. And we're going to set that equal to the reverse of the normal of the collision, and then multiply that with our velocity length. This probably isn't proper physics. We're not taking into account the Husky's mass or anything, but it's fine for this workshop. Sorry, have the impulse there. And make sure you have that negative sign in front of get normal. All right, once we have our impulse, we should just apply that impulse to the rigid body. So apply central impulse, and then just pass the impulse. All right. Wait for everyone to have that down.
Oh.
Yeah, get off your phone.
I'm sorry. Work is texting me. I have a JOB trigger warning.
What's that?
I have a JOB trigger warning. Job.
Oh!
Oh,
Oh,
don't say that word.
Trigger warning.
All right, everyone has this down?
I got it.
All right. Now, if we run our project, we should be able to kick the ball.
Oh my gosh.
Good to go. Everyone has this?
No.
Does this work?
I think I missed a part where the collision stuff initially
It's so silly.
before this last part we had. I guess not.
Such a meme I saw online where
How?
was
Never
able
spelled
to
the
kind of
word
stop when it hit the
tree.
ball.
I lost the
But mine
ball,
just
it's
kinda
gone.
faced
It's
the ball.
gone.
But it also
Oh, I think. Oh,
That's
but
weird.
there's
Can I
the
see
code.
code?
because it was doing that before this last step.
Wait, let me try again.
Yeah.
What am I gonna get? Wait, I got you.
Wait, James.
That's fine.
Why is it the Husky returning?
My slides off.
Huh.
Did you turn on
Well, can you play it again?
I did.
Just real quick.
That's okay.
I
I
don't
will
know why
have
it's
to save.
delayed like that. That's kind of weird.
Wait, what's happening?
It's really, oh, okay. Go back to your scene tree. Actually, stop playing because that's the. All right. So under ball, can you click 2D to 2D view? Yeah, your ball doesn't have a collision chip. So click on collision chip. Oh, it's at 0, 0. Okay. So at transform, it should be 0. Oh, your sprite. Okay. Scroll down to your sprite. You set the transform with your sprite instead of the actual ball. So you want to reset the transform with the sprite to 0. Yeah, your transform.
This one?
Yeah. And now you want to click on ball, and then move the ball.
And then move the ball.
Yeah, move the ball.
With this.
Yep. And that moves the parent node and the child nodes.
Right. Okay. Because I just moved the ball.
That's why it was a little offset and weird. So now if you hit play, it should be working.
Is it normal that when I hit my ball, it goes all the way off the screen?
Yeah, so normal.
Yeah, you weren't paying attention. We set the damping variables.
I set that to 2. Is that not what I was supposed
You
to
do it for there's 2 damping things.
Oh, there was?
Yeah,
one
there's 2.
Angular and
There's one for velocity, or sorry, linear and
yeah,
angular.
Oh. See, James gets mad at me for not paying attention, but if there was another member, he would have been like, oh, let me see. Oh, it's okay. I'll fix it for you. But with me, he's like, you're not paying attention. I'm on that phone.
They're not on their phone.
You see that? You see that?
So one person's on their phone and the other isn't, all right?
So mean. So mean.
Okay. All right, we have ball kicking. And this is a little optional, but we also want to give the ball a little rotation, right? So we're gonna call another variable called torque. And this might seem a little random. It just looks nice. So I pick a random float value between 2 and 4. And then I use the impulse length. And then I find the direction, the x direction of the impulse. And basically, this will make the ball roll in the direction that you hit it, and give it like a random bit of impulse torque. So it rotates a little randomly. There's some variation. All right, and then apply central torque. Sorry, not impulse. apply torque impulse. That's what it's called. Make sure it's a applied torque and not impulse, central impulse. Grog it?
One second. See.
I could also zoom in a little bit. Oh, then it gets off the screen.
Okay, sick.
All right, and if we hit play
The type and workout.
and we kick the ball, it's gonna rotate.
Oh my god, that's so cute.
Wait, can I see the code for?
Yay!
Yeah.
I might have done something.
Doesn't launch off the screen anymore?
No.
Oh, I see.
This is so whimsical.
This is so whimsical.
Oh, that was a goal.
Everyone has this? We're all good?
Yeah.
All right. Next up, we're going to make the goal, the soccer goal. Super simple, super easy. I'm gonna add another child node to map. We're gonna use a static body this time because the goal is not gonna move. Again, we can move the object a bit up, maybe like, I don't know, -64. You can set the transform and make sure you're moving the static body and nothing else. So make sure it's selected. You always want to pay attention to what you're selecting in the scene tree. Okay, and we're going to call this goal. And I like to organize it a little bit. Probably like put it up here. Doesn't really matter. All right, so under goal, again, we're going to need a collision shape. Oh yeah, and then a sprite. All right, for sprite, again, same thing, quick load, find the sprite. It's going to be called goal.png. Look at that, we got a little goal. For the collision shape, actually, we're not going to use collision shape.2D. We're going to use a different type of collision because we want the goal to have a little bit of fancy collision. So it's like, it's a little concave, not convex. So we have a little bit of space inside. So we're going to add a child node, and it's going to be, it's a please type, collision polygon 2D. So this will allow us to create a polygon shape for our collision.
Interesting.
All right. Now to edit the polygon, make sure you have select mode here and not move mode. Otherwise, you're just going to move the object. And then you can start creating your polygon. So I like to start top left here, like maybe in this corner right here. And it should snap to the grid. And we're just going to outline a basic collision shape of the base of the goal. Just like all around here.
That's so cool.
I'll just go a little bit. Oops, I made a mistake. So once you complete the polygon, it will draw and fill in like this. And then if you made a mistake, you can just drag one of the vertexes into place. And it should snap to the grid by default. If it doesn't, then you're just gonna have to eyeball it. Or you can enable grid. But I think it should snap. What happened?
I can turn on.
Oh no. Alright. Does everyone have this? We're all good? Are we still making the polygon?
Yeah.
Where are we at?
I'm trying to make it.
What did you set as the shape for the goal?
You have to make it a collision polygon. Don't make it a collision shape. Make it a collision polygon. It's a different node.
Oh, so I think I
Yeah.
accidentally.
It's so cool. Oh, wow. How'd you get the colors?
Actually, if you use a collision shape, you'll see that if you click on shape, you'll see that there's a concave polygon shape. It actually doesn't work with collision shape. It just won't work. So
That's weird.
don't do that. Yeah, I don't know why Godot displays that, but there's an issue with that. I think. Last time I tried to use it, there was an issue with it. I don't know if they changed it or fixed it or whatever. All right, so we have our collision polygon and we have outlines the base of the post. Everyone has that? Mm-hmm. All right. So if we hit run, we'll see that if we try to kick the ball into the post or the goal, it stops there. Nice.
You can walk behind it.
And you can walk behind it too because we have white sort enabled.
And you can see yourself behind it.
This is cool.
All right. That's basically the game, but we do want a victory screen, right? When we make the ball into the goal. So we're gonna make a little UI. UI in Godot is called control. So all control nodes, basically you have like containers, your text, your line, your labels, your menus, your panels. They're all controls. And controls are kind of like Node 2Ds, but they provide you your anchors for editing your UI, right? Like in Unity, you have your canvas and then your canvas items, right? In Godot, it's called control. And actually, I forgot to do this. We have to actually add a canvas layer. So this canvas layer, it basically splits like all your canvas. So nodes and controls are canvas items, and we want to draw our UI over our map, right? So we have to split it into a canvas layer, and it should have a layer of 1. And then this control, I should have made the canvas layer first, but this control should be a child of canvas layer. And then I'll just call this control UI. And if we zoom out, we'll be able to preview our UI. So you see this blue bounding box? That's our viewport. That's our viewport rect. And all the UI is going to be built relative to that viewport. So yeah, this blue rectangle here. It's a little faint. Can't really see it, but on your screen you should be able to see it. Under Layout, click on UI, your UI control. We're going to make this a full rect, so it spans the whole viewport. And that's it. Now, to make like victory text, we're going to make a label node. And you can see it's a child of control. We're going to make that a child of UI. And you can see it's in the top left here. If we add text to it, say victory achieved, you can see that the label is drawn. And if you run the game, it will be drawn in the top left here. But let's say we want to make it centered. We go here down to layout again. This is where you'll be making a lot of your like UI positioning changes. It's always under layout, under control. And then I like to work with anchors. Some people like to use absolute positions. Anchors are generally like what you want to use. And then here I'm going to use a full rect, so it spans the whole viewport. And then up here I'm going to make it centered. So just to reiterate, under layout, we want to make it full rect again, just like our UI control. And then horizontal and vertical alignment for our text is going to be centered. Does everyone have that?
Oh.
You don't have that. It's all good. Is it like dead or something? Or?
No, I think it has to do with the graphics drivers with Linux. It like are not compatible, so it crashes. Which is
That sounds bad.
Yeah.
All right. Everyone has victory achieved in the middle of their screen. And if you hit run, it should display right in the middle. Everyone has that? We're all good? Okay. Just making sure. All right, once we have that, ooh, it's 11:50. We could go on a little beyond 12 o'clock, I think. Are there any reservations? Could you check? Or maybe if they knock at the door, we could wrap up real quick. All right. But we don't want this displayed, so not yet. We only want it displayed when we make a goal, right? So we're just going to hide it using this eyeball icon here. This eyeball icon is called visibility. You can toggle visibility. It's also this property here in the inspector. It's called visible.
We're in 301, right? Or
305. LB2 305. Uh-oh. That does not sound good. Lock in. All right, we got 9 minutes. All right. And we'll also add a restart button too, if we want to restart the game. So we'll make a button control. Oh, also name your controls. We're going to be referencing these. So the label we'll call victory. And the button we'll call restart. And then our restart button, we'll just put the text as restart. You can keep it top left. I like to put it in the bottom middle. So I'm just going to do center bottom. You can put it anywhere you want using the anchors. All right, run the game. You can see we have this restart button, but it doesn't do anything. So we're going to be adding functionality to that very shortly. Everyone has this? We're all good? Mm-hmm. All right. Let's make our main script. So our main script is going to handle the victory and the restart button. So under assets, we're going to do, actually, we should do it the other way. There are multiple ways to make a script. Up here, we can right click and attach script. And here, it already populates the inherits node2d, and it gives a path, and it renames it to the node name, which is very convenient. So all we have to do is just create. All right. Now, we want to get our victory label and our restart buttons using onReady again. So we'll do victory label equals, it's going to be under canvas layer, and it should autocomplete for you. If you have the script attached in the scene, it will make autocomplete suggestions for you. So it should be canvas layer UI victory. And again, cast it as label. And do the same thing for our button. All right, once we have this, we're going to do in our ready function, we want to detect when the button is pressed, right? And restart the scene. So with restart, button has a thing called a signal. Signals are equivalent to events. They're just the same thing. It's one-to-one with events. So the signal is called pressed. Right. So when the button is pressed, it's going to call the signal. And any function that we connect to it will be called. So let's make a function called on restart pressed. You can call it anything. No parameters, just a void return. And we'll just copy and paste that into connect. So when the button is pressed, this function will be called. All right, and when we press that button, we want to restart the game. So the way you can, this is one of the ways you can restart a game. It's super simple. You just call get tree, which gets like the scene tree, and then reload the current scene. I do not recommend this in actual games. I recommend that you have your own loading and unloading system where you load and unload your own scenes and have like a main scene that you never touch and never unload unless you quit the game. But for this workshop, just get tree, reload current scene. That works just fine. All right. Wait a second for everyone to type this down. All right, we're all good? Okay. And again, if you want more information on like what you actually just typed just now, you can like hover over and it gives you documentation. And also if you control click like on a method, it'll take you straight to the documentation. And all the documentation is built into the Godot editor, so you can view it offline as well. Unlike Unity, which just takes you to like encode that tells you nothing. All right, we're all good? And if we hit play, let's move around a little bit, kick the ball maybe, and then we press restart. It restarts the scene. All right, I'm gonna get moving along a little bit because it's almost 12. Now we want to detect if the soccer ball actually reaches the goal, because that is our victory condition. So back to our 2D scene. Under goal, we want to be able to detect when the rigid body ball actually enters the goal. So we're not going to do like a collision check if it hits the goal. Instead, we're going to use another kind of physics object called an area. And we're going to make this a child of goal. And we should see it should be located right here in the center, and we're going to give it a collision shape. So in Unity terms, an area is the equivalent of a trigger. So if a physics object enters it, it's going to call like, oh, this body just entered, or this other area just entered this area. So it's going to have, again, signals that we can use. Now we need to give this area a collision shape. We'll give it a rectangle, and then we're just going to use the gizmo to move it here to fit the goal. And I like to put it just a little bit inside the goal. And that should be it. That's our area. Oops, it's a little. It doesn't really matter, but make that exact. All right, everyone has this? We're all good? All right, now we need to reference this area. So we're going to make another onReady. We're going to call this I'll call it goal area. It's going to be an area 2D. And this is going to go all the way down to map goal area 2D. All right. We have our goal area, and we're going to use the signal called body entered. And anytime a rigid body or a character body or any kind of physics body enters this area, this signal will be emitted. we're going to do connect, and we're going to make another function called on goal area body entered or something, or you can call it foo or your cool function. Call it anything. And it needs one parameter. This is very important. It should be called body node2d. And how you know if you need to add a parameter to your signal callback, it's called a signal callback when a function is called by a signal. You can hover over the signal name and it'll show you the parameters here. So it's going to pass a body to the function that you connect it with. So let's add our function here. Should be good. And now we need some code to check if this is actually the ball that's entered the goal. So right now, this function will be called if the Husky enters the goal and if the ball enters it. So we want to filter that out. One way to do that is to check the name. Do not do this in your actual games. You should use, there's a thing called node groups. There you can add a property. You can use a class check. But for this workshop, we could just check the name because we know the name. The name is ball. And if it is that, then we want to display our victory text. So victory visible. It's the same visible icon property that we modified, and we want to set it to true because it's right now it's false, right? It's invisible when we play. All right, everyone has that?
Yeah.
Okay.
I got a little behind. My stuff's broken when I was copying.
Alright. Alright. So once we have that, we could run the game. And there's an error because I'm really dumb. I messed up. Oh, I forgot a slash. My bad. Oops. Now, if you kick the ball into the goal, yay, victory achieved. And that's basically the whole game. There's some extra things. So if you notice, you can kick the ball off screen. You can add like world bounds. So I'll show the final projects that I wanted to get to, but we didn't have time. Let's see. Again, this is also in the workshop files in the channel. So this is the final projects I wanted to get to. Yeah, so we have like cherry blossom leaves falling. And if you notice, if we try to kick the ball off screen, we can't. There's actually collision. Yeah, so we missed out on GPU particles and the world bounds, but that's all right. If you want to see the original project, again, if you go to the workshop Discord under project downloads, it's this complete project right here. Yeah, and also you can go into code and under the master branch. Oops, where am I? I'm under tags. If you go to master branch, you can see all the original code here. And all of the original code has documentation. So there are a lot of comments explaining what each line does.
Yay!
All right.
Everyone say thank you, Jay.
That's really cool.
Yep.
Thank you for putting this together.
Last slide. Here's some optional challenges if you want to do it at home. You know, like add obstacles for the ball, add a sound. We didn't get into sound, but you just add a sound node. It just plays a sound. And yeah, that's about it. Thanks, guys.
Yay!